Okay, so here's our second section of Chapter 7 on energy. And I'm going to chat about nuclear energy now, which is another form of energy consumption. Talked about coal, natural gas, and after nuclear energy, I will go into um, oil. Okay, so nuclear energy. Now, what's the difference between fission and fusion of atoms to produce energy? Well, fission is the splitting of atoms to release energy. Fusion, on the other hand, is the combination. So one is obviously division, and the other one is combination. Combination of atoms, again, with the release of energy. So both seek to release energy. Now, the appeal of nuclear energy, because the fission of a uranium atom produces 10 million times the energy produced by the combustion of a carbon atom in coal. So it just produces so much more energy. One can almost say that in terms of energy production, there is no scarcity of nuclear energy. But as we'll see in just a little bit, there are plenty of other problems with nuclear energy. Now, how many nuclear reactors do we have? There are 103 active nuclear reactors in the United States and 400 around the world. Let's see, 162. Yeah. Yeah. Oh, excuse me. There are 99 active nuclear reactors in the United States and 450 in the world, according to the fifth edition. Um, okay. Now, there are several environmental threats with regard to nuclear power, and there's two major ones. One is the storage of spent radioactive fuel from reactors and the possibility of accidents. And unfortunately, there have been some doozy accidents. The biggest one was in a commercial reactor in April 26, 1986, and of course, I'm talking about Chernobyl. This killed 32 workers, thousands more in the following year. The plume of radiation reached all over the world, and within Chernobyl itself, it will take perhaps thousands of years, hundreds of millennia before humans can live there again. So we basically, because of this burning of the core, created a absolute no living zone in the Chernobyl area, and I believe this is in the Ukraine. And and there are definitely health and environmental risks with regard to storing nuclear waste as well. So the potential, the benefits are incredible and probably much cheaper relative to and cheaper in terms of the environment and the production. But when there's an accident, oh my goodness. And Fukushima, if you remember, I think this was again back in 2012. Um, there was a typhoon follow right on the heels of a almost a nuclear meltdown, and Japan is still dealing with that. That's in the northern part of Honshu, in a place in the prefecture called Tohoku. Okay, here's your author at a nuclear power plant. All right, where are we going to now? Oh, yes, that other fossil fuel. That would be oil, of course. And so, what exactly is oil? And according to your book, it's the formation of aliphatic hydrocarbons. Hydrogen and carbon atoms link together to form molecular chains of all lengths. Shorter chains are liquid at room temperature, longer chains form solids. In the refinery, distillation separates the hydrocarbon chains into fractions that can be blended to produce fuel with desired characteristics. So there's all kinds of different fuels that can be produced. It can be jet fuel, fuel for cars. California has its own special blend to decrease the amount of air pollution going into the air. And so yeah, you can form, as your book says, kerosene, diesel fuel, fuel oil, lubricating oil, and asphalt. Now, where is the oil, aka the black gold? um, well, it is all over the world, but in just select locations. And United States is again a big producer. The Persian Gulf area, Venezuela has the largest reserves in the world. Mexico has a lot of reserves, and so they're around, but they're not nearly as numerous as one would say perhaps coal might be as numerous. And this gives power and wealth to the holders of oil supplies. OPEC, Organization of Petroleum Exporting Countries, provides almost half of the world's oil, and through its cartel has a strong influence on oil prices. When OPEC wants to hold back oil from the market, that absolutely can draw up the price of oil and or gasoline. Now there are private and social costs to oil. The private costs in the U.S. Definitely low relative to many industrialized nations around the world. We have relatively low taxes, but these low private costs mean that there are higher social costs that are not necessarily internalized by consumers out there. So, especially in the United States, low private costs and high social costs. Okay, and here is the oil demand and supply market. And for oil, we're assuming that it is something of a monopoly where we're producing it where marginal revenue is equal to marginal cost, and um, we see that the competitive output and price is where private marginal benefit is equal to private marginal cost. Oh, excuse me, this is competition, and that would be quantity of Q, price of P. Now, if we are a monopoly or a cartel, it would try to restrict output and price. That would be Q star and P star. Again, producing at where MC equals MR. Oh, I see. In the competitive situation, you wouldn't have MC equals MR there. But in the monopoly, obviously you would. Now, ironically, this output and price would be socially efficient as well. We reduce gasoline, oil production, and gasoline consumption, and that would obviously lead to less less impact upon the environment, less externalities, as it were. So, thus, government may want to tax the producer to reach this point. And we've talked about that before. What a tax would do to deal with a negative externality. Now, if the social cost was MC2, then the monopoly price and output would be too low, and the competitive outcome would be excessive. Excuse me, MC2. The monopoly production level would be too low and potentially less efficient than the competitive outcome. So then it would be good to be at the competitive point. Okay, what do we got next here? Alternative fuels. So there are all kinds of alternative fuels out there. We first have biodiesel. It's a cleaner burning diesel fuel made from renewable plant oil or animal fats. It can run in current diesel engines, either blended with petroleum diesel or straight. Electric fuel, as are electric vehicles. I would assume it would be running from electric power. and they could be come from solar panels or transported from power plants. So electric fuel, for lack of a better term, would be electricity. Um, and he talks here about some electric vehicles are expensive, but the cost has definitely gone down for electric vehicles. Tesla, um, my goodness, can travel at 244 miles on a single charge, and that pack lasts 7 years. We have a Prius, and our battery lasts about 7 years as well. Ethanol is a clear, colorless liquid with an agreeable odor and a sweet taste. It is distilled from a selection of renewable sources that it can include corn, barley, wheat, and waste accumulated from wood and paper processing. Ethanol is very popular in the Midwest. And oftentimes gasoline has an ethanol mixture to it. Hydrogen. Hydrogen gas can power combustion engines and fuel cell vehicles. And this is electricity generated from the reaction of hydrogen fuel and oxygen that from the air that provides fuel cells with clean, quiet power. The only emissions are pure water and heat. And while this sounds great, the challenge, though, is to safely distribute and store the hydrogen. It's an explosive gas at room temperature. So while we have the mechanism to distribute gasoline, we certainly do not have the infrastructure to distribute hydrogen. Methanol is a gasoline additive, and it's a replacement for gasoline and diesel fuels and a source of hydrogen. Methanol includes natural gas and many renewable resources, including carbon, seaweed, waste wood, and garbage. And relative to gasoline, methanol offers lower emissions of all of the bad things. But its fuel efficiency is less than half of gasoline. So it's not nearly as efficient. Maybe cleaner, but not nearly as efficient. Okay, we've got now propane, or LPG, is primarily propane and contains a mixture of hydrocarbons, butane, butylene, and propylene. It's a byproduct of petroleum refinement and natural gas processing. And propane is oftentimes used in out of the way places, like in Volcano Village on the Big Island. Almost everything runs on propane, and you buy the propane and you use it selectively. Propane has been used in worldwide for 60 years, and there are 350,000 propane powered vehicles that are driven today. Propane is 270 times more compact than as a gas, or as a liquid, I should say. And propane fuels cause less carbon buildup than gasoline or diesel, allowing spark plugs and engines to outlast their counterparts in gasoline and diesel. Oh, that's interesting. We've got P series and D series. P series is a combination of ethanol, natural gas liquids, and biomass derived. Oh, I can't even pronounce that. And it comes from renewable sources. D series is another complex mixture of renewable and fossil fuels that provides a cheap, cleaner alternative to gasoline. We have solar fuel. The energy is out there, but the problem is collecting it. Solar thermal applications use the sun's energy directly to heat air or liquid, primarily for electrical use. Solar panels or photoelectric methods use semiconductors and photovoltaic cells to convert solar energy into electricity. Okay, and there's a chicken and egg problem with regard to the production of solar panels, and to produce more would cheapen the price, but you need a market first to produce more. But I understand China is producing a tremendous amount of solar panels, and that alone is bringing down its price. And we've got wind, and wind power has been around for hundreds of years. The Dutch are very good at wind power to drain their areas, drain into water. And small wind turbines can create energy using a minimum of 8-mile-per-hour winds. Large turbines require 13-mile-per-hour winds to achieve efficiency. And through this wind, energy is created, electricity is created through the force of the wind, spun by the force of the wind and creates electricity. Wind turbines offer an infinite source of kinetic energy and create no emissions. There are some environmental concerns about birds being swept into the rotors, but collisions are uncommon. The Danish Ministry of the Environment reports that power lines from any source are a far greater threat to birds than wind turbines. There's a majority of wind turbines are located in California, but there are many in Texas, and we have quite a few here in Hawaii. In the Kahuku area, we have a lot on the North Shore. Maui has a tremendous amount, and I would assume the Big Island and perhaps Lanai does as well. And finally, we have geothermal. It is heat held beneath the Earth's crust, and this energy can be brought up to the surface to heat buildings or icy sidewalks or converted into electricity. So Chevron plans to double its geothermal capacity in Indonesia and the Philippines. We in Hawaii have geothermal. We actually had a big geothermal plant that unfortunately was right on the lava path of Madame Pele when Kilauea did its last eruption. So geothermal is a definite fuel source. It's a definite energy source out there. Okay. There's a mention here about direct use geothermal systems in Iceland. Pump hot water from underground directly into buildings and greenhouses for heating, and below city streets for effortless snow removal. Residents of Klamath, Oregon, cherish the safety of their snow-free streets and sidewalks, all cleared by naturally hot water piped beneath them. And these next few slides are going to be pictures. This is fuel cell vehicle and a hydrogen station, and how that process is going to happen and occur. This slide is a solar-powered car designed by the University of Michigan Engineering Program. And there's, of course, a solar-powered plane that flew entirely around the world. It was done primarily through solar panels. Here we have a series of wind turbines. Anybody who lives on the North Shore should be familiar with that site. Some folks feel that these things are unsightly, and others just look at the clean energy that's being produced by them with no emissions whatsoever. Alrighty, and I do believe that finishes up this second section of this chapter.